Hello, everyone. Good morning, good afternoon, and good evening to all. I am Anisha Mishra, the moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the first series of World Conference on Information Systems for Business Management. I hope you will find this session interactive and knowledgeable enough. So there is a special note for all the presenters. You all will be given 12 minutes for your presentation and 3 minutes for question and answers. And on 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of this session. Just a second. Professor Parikshit N. Mahale. Professor Parikshit Narendra Mahale is professor and head Vishwakarma Institute of Information Technology, Pune, India. He completed his PhD in computer science and engineering, specialization in wireless communication from Aalborg University, Aalborg, Denmark. He has more than 19 years of teaching and research experience. He is reviewer for Springer Journal of Wireless Personal Communications, also reviewer for Journal of Engineering Science and Technology, School of Engineering, Taylor's University, reviewer of Elsevier Journal of Applied Computing and Informatics, member of editorial board of IEEE Transaction on Information Forensics and Security. And we have another session chair for this session, Professor Varsha Damodar Jadhav. Professor Varsha Damodar Jadhav is an assistant professor at Vishwakarma Institute of Information Technology, Pune, India. She has professional experience is 18 years and her research areas of interest is machine learning, artificial intelligence, data science, data structure, design and analysis of algorithms. Her research interest is data science. She is a reviewer at International Conference on Smart Innovations in Design, Environment, Management, Planning, and Computation. I welcome you both to the session, sir and ma'am.
Thank you so much.
Thank you, ma'am.
So now we'll start with our papers, and I would like to invite our first presenter, L. Imtiaz, to present his paper on the title Arduino and Node MCU based Smart Soil Moisture Balancer with IoT Integration. Dear presenter, you may please start your presentation.
Thank you for the opportunity to present my work. Here I am sharing my presentation slide. Is it visible to you?
Yes, it is visible.
Okay, thank you very much. My topic is Arduino and Node MCU based Smart Soil Moisture Balancer with IoT integration. Myself, Al Imtiaz, from Department of CSE, University of Information Technology and Sciences. So here are our contents, why we are developing this type of project and how we have developed. We will describe those components and slides later. First of all, motivations. As we know, Bangladesh is a developing country, and our farmers till now are using a manual irrigation system, and this is not a efficient and effective system for farming, because we have opportunity to over irrigation, under irrigation, and improper water distributions, which are also harmful for the crop. And here we are not taking care of the soil type, what type of soil we are farming and what type of crop we are farming. So if we can design a system where we will take care of soil type and we sense the soil moisture, and based on the crop we can irrigate, then we will get the better result. So according to our motivations, we try to design a prototype, and here are the devices we have used so far. Node MCU, and some motor, and a display and sensor. Here is the main block diagram and system model. Here we can see that we have used a Arduino, and here is soil moisture and water pump, a water integrator to check if we have enough water or not. Then a relay to control the pump, and a water flow meter to detect the how much water we are irrigating, and node MCU to collect the data and send it to the server through internet. Here are the actual devices we have used. Here the sensor, the relay, the water meter integrator, the device node MCU, and the motor and the displays. In the next slides, we can see we have a flowchart. In this flowchart, we can see, sorry. I'm not in full view because of here we can I can use the zooming options. Here we can see that according to the flowchart, after we start, we will initialize the system, active all the sensors we have, then we will check the water, does we have enough water or not, and check the soil moisture by a sensor. After that, will our display LCD display display the information as per the sensors, and after that our based on our algorithm, where we can set a specific moisture sensor based on the soil type and the crop. Based on that value, we will check do we have to do you have need more water on the soil or not. If it is yes, then we will turn on the pump. If no, then we will turn off the pump. After that, this message will show on the OLED display, and all the informations how much we are watering in the soil we will send to the things speak through the data channel. Next is this is our prototype, what we have designed so far. And here we can see we have loamy soil. We have designed we have checked our system with 3 types of soil. One of sandy and clay, and other one is loamy. And here are the prototype, and we are using moisture sensor and water pump, and we have checked with our prototype with sensor and without sensor, and how much we're saving water. And here is the data we have sent to the ThinkSpeak, and here are our data what as per our experiment. Here we can see that we have sandy, clay, and loamy, the 3 types of soil, and here are the moisture sensor data. And we can see that if we use moisture sensor, then we get then we have to provide less water than the regular. And how much less? Here at the result, we can see the consumption with sensor is very useful. We are saving at most 30 7 to 35% in average. And at the end, here is the conclusion, very a small presentation. I have tried to make it short due to lack of, I have lots of descriptions which all are available in our paper, but here are the important sections are available in this presentation slide only. We can say at this point, we can say that by using this prototype or this proposed system, we are saying that it can save our water, and it will be helpful for the farmer because how much need the watering we can provide the according to the need. And another thing is there are lots of similar projects available, but in this experiment here we use 3 type of soil, and we try to focus on the soil type and the crop type. And based on that, there is an option in our algorithm so that we can configure based on the need. And so far, this is my presentations, and thank you all. Thank you, sir and madam. If there is any questions, that will be appreciated. Thank you.
Yeah. Can you hear me?
Yes, yes, sir, I can.
Okay. Can you stop your presentation?
Okay. Thank you.
Yeah. So which sensor you have used for this measurement?
Sir, sir, moisture sensor.
Moisture sensor. And
Its name is FC28.
okay. And what is the total cost of your entire setup?
Bangladeshi, according to Bangladeshi Taka, is 2,000 around.
So how it comes in dollar around?
$20.
$20. And in your presentation on the last slide, you mentioned that you have saved some 36% for some type of soil, and then some 31% for another type of soil. So how you have measured this improvement, particularly with respect to water saving?
First of all, we have used regular irrigation system, and a continuous. We have measured the continuous water flow based on the time, and after that we have used a sensor, and based on the need of the soil, and we control the water flow, and we measure the total water amount, and we find out that different type of soil need according to the needs. We are controlling the system irrigation, and we compare the total amount of water irrigated to the farm, and that's how we have prepared that.
Thank you. Thank you. Over to Arsha, madam.
Yes, Imtiaz, can you hear me?
Yes, I can.
Yes. Have you noticed any difference in the soil parameters between the urban and the countryside region if you consider some pollution or soil impurities into it?
Madam, it's a very nice observation. But till now, we are working on the soil type and crop type, and we will include other parameters in our future.
Okay, thank you.
Thank you.
Over to you, Anisha.
Yes, ma'am. Thank you for your great presentation.
Thank you. Thank you for letting me.
And now we are moving further to our next presenter, Win Din Nguyen, to present his paper on the title, Robust Plant Leaves Diseases Classification Using Efficient Net and Residual Block. Dear presenter, you may please start your presentation.
Yes, thank you very much for your introduction. May I share my screen now? Yeah. Yeah. Can you see my screen?
Yes, I can see it. Please go ahead.
Yes. Thank you very much for your introduction, and hello everyone in this session. And now I would like to present our research about the robust plant leaf disease classification using efficient nets and residual block. And in this presentation, I would like to divide my presentation into four parts. The first part, I would like to give brief introduction why what is the main motivation why we do this research. And second, from the motivation, we try to propose some methods to improve the accuracy of plant-leaf disease detection. And next one, we come to the experimental result to describe the several results from our experiments. And finally, we come to the conclusion and the future work. As you know, in the Vietnamese agriculture aim to develop the sustainable intensifications with the help of modern technologies. Therefore, it is necessary to provide the intelligent system by AIs to help the farmer analyze and isolate the plant-leaf disease to increase the plant health and productivities. And currently, various systems have been proposed to detect and classify the plant-leaf disease, such as convolutional neural network, support vector machines, decision tree, KNN, and random forest. But currently, the performance of this system is still not satisfied for the reapplication in terms of the accuracy, also the processing time. And here I would like to review a little bit some kind of object detection algorithm from the history up to now. Currently, we can classify the object detection algorithm into two approaches. The first one is the one-stage method, and the second one is the two-stage methods. For the one-stage method, such as YOLO, SSD, and Retina, it obtains a really fast processing time, but somehow the accuracy may not compare to the two-stage methods, such as factor CNN or paradigmatic network. There are some trade-off between two approaches, and up to now, just a few years ago, there are some algorithm it's in the efficient net proposed by the Mission Tang and Berkeley, and this is quite interesting research. In here, they propose a method for the one-stage learning methods by proposing the efficient net. In this case, they consider several impacts if we want to increase accuracy of the system. The first one, if you want to increase the accuracy of the system, we can consider to increase the with scaling. That means indeed the scaling size of the network in terms of the layer. And the next one, we consider obtain about the number of units in this layer. And the last one, they can consider about improve the resolution. And in here, if we want to improve accuracy of the network, we have considered one of three impacts. And what will happen if you can compile three modifications at the same time, like there for the robots. The new one is compound scaling. It is quite interesting idea to improve. It's also the main motivation for us to, based on this idea, to develop a technique to detect the plant-leaf disease. And this is the result. I would like to quickly review a little bit result from this paper. In here, the efficient net obtained 5 good results compared to existing ones. In case they develop several versions from B0 to B7, so upgrade the networks. And you can see that when we increase the number of parameters, the efficient net obtained better result comparing to another one for residual network, inception, and another ones. And based on this idea, we try to prove efficient net to our systems. In here, we try to use the efficient space network to provide the feature, because we want to our system to provide the compounding feature to robust the more robust feature. And then we try to design another deep neural network to attract to learn the feature. For example, in this case, in efficient net, we try to reveal about 1,280 input feature. And then we try to design the neural networks with the several layers and start with the pseudo block to detect around 5 plant-leaf disease you can see here. And a little more detail, how can we design the network? We try to add the pseudo block for each layer. So after we apply efficient net to provide us the robust feature by using the idea of compound scaling. And the next one, we try to train our system on this current communication. Currently, we use the PC with Intel Core i9 CPU and 64 gigabyte RAM, and we have the true NVIDIA GTX 3080 with 10 gigabytes. And for the data set for experimental results, and here we use the Kaggle Plan DC, which provide us with around 87,000 ISBM images with different class. But in this research, we try to focus on the 5 main class. And also, we also set up and capture some our data sets in the country city of Vietnam to verify the performance of our results. And it is some sample results. And the left side, you can see that it is the sample image from the Kaggle dataset. And the right side, you can see that it is some sample we capture by using the camera in the country city at Vietnam. And the next one, I would like to show you some experimental results when we're comparing our methods with the existing ones. In here, we divide our data set into 2 parts, that is train and testings, and comparing the detection rate and the font alarm rate of our proposed methods and the other ones. And here we can slightly increase the performance of our proposed method comparing to the other one. This is the traditional algorithm, the CNN, supporter machine, KNN, decision tree, or random forest. Indicate this table present the results by for the plurally held data sets. And in order to verify the custom data set captured from our experiments, we also perform with the blueberry disease, as you see in the previous slide. I show some sample image. In here, you can saw that we can also slightly increase the performance of the system comparing to the another algorithm, look like CNN, supporter machine KNN in here. And another one, I would like to present the result for another disease-able platform data sets from the Kaggle. In here, you can saw that our system also obtain the acceptable rate or comparable rate detection rate comparing to the other ones. And next one, we would like to come to the conclusion session. In this case, in this research, we try to pursue an efficient approach to classify the blended disease by using the benefits of efficient net and pressure block. And the system somehow it can slightly obtain a better result comparing to the traditional methods. However, our system still have several limitations. The first one is if the input image affects some noise, some illumination change, or some noise appear during the experiment, the accuracy of our system is decreased. And the second one is the complexity of the network. Therefore, in the future, we plan to improve the current because we want to apply this system into the mobile device to have the farmer easy to use this device to detect the blended disease. And this is the end of my presentation. And thank you very much for your listening. And do you have any question?
Yeah, good presentation. Can you hear me?
Yes, I can hear you well.
Yeah. Can you explain how this residual block mechanism works?
Yeah, in here, currently for the traditional neural network here, we just provide the inputs only and compute some weights and latent with compute outputs. But therefore, we missing information from the original. Therefore, the pressure block can compile. That means after process one part to process the original information, and then you can compile. That means the fusion the information from original with the new one. So we can keep the original feature and the new feature at the same time. It's a quite good idea to maintain the feature.
So in your entire research, you have used the binary classifier or multi-class classifier?
I see the multi-classifier because in this case we can classify the 5 theory here, and we show the multi-class function to classify here when design a neural network.
And what about YOLO? You are talking about some YOLO and activation function. So can you elaborate more on it?
Yes.
Okay. Can you go to the last slide where you have presented your
so,
results slide? The previous one.
Yeah, previous.
Yeah. So you have done experimentation with around 5 classifiers, right?
Yeah.
Okay, and everywhere the training samples are same, testing samples are also same, and there is a big difference with respect to maybe you're getting better than CNN, right?
Yeah.
Is 2. So what is the reason? Can you explain why you have received such more significant results here?
Currently, actually, the main reason is that comparing the traditional convolution neural network here, the author just decide the normal convolution neural network. I mean, they decide just accept several player. They didn't apply the compound scaling here. Because actually, I saw that the compound scaling idea from the efficient is quite interesting idea because we can increase the accuracy, and you can saw here. With the original paper, when they apply the efficiency, they can significantly increase the accuracy of the system. Therefore, that is the reason why our system obtained better result comparing to the original CNN.
Right. Thank you. Over to Varshaman.
Yes, thank you very much. Yes, excuse me, I cannot hear you, sir.
Yeah, fine. I'm done. Thank you. Over to Varsha madam.
Yes, can you hear me?
Yeah, I can hear you.
Yes, yes. So you have used Kaggle dataset?
Yeah, I use Kaggle
Yes.
dataset.
Okay. So have you tried it with any input image from a live plant?
Yeah, in this case, I just try to take a non-normal condition and we try to capture the real image from our camera to real size. But I usually discuss that with the real image, our system the accuracy of our system is decreased because as effect of the noise and implementation chain. Therefore, in the future, we try to increase the accuracy by applying some techniques.
Okay. So can the experimentation here be used for multiple plant species in future?
Yes, yes. In future, we try to apply, and we plan to implement my system on the mobile device because we want to have the farmer to use our system and easy to detect the plant, and they can have another option to increase.
Okay, fine. Thank you.
Yes, thank you very much.
Presentation was good, nice.
Yes, thank you very much, sir.
Yes. Over to you, Anisha.
Thank you for your great presentation. And moving further, I would like to invite our next presenter, Taslima Noor, to present her paper on the title, A Review on Twitter Data Sentiment Analysis Related to COVID-19. Dear presenter, you can start your presentation. Okay, so she is not in the session.
Yeah, I think she is not there.
Yeah. And we don't have any of our next presenters in the session.
So we have to wait.
We'll wait for 5 minutes. And if nobody joins, then we'll end the meeting here.
That's fine. We'll wait for 5 minutes. No problem.
Okay. So while we are waiting for the participants, I request two session chairs, if they want to discuss anything with the participants, then they can share, please.
No, that's fine. Both the presentations were
Okay.
good. Do we have few more presenters in the queue?
No, sir, not yet.
Okay, all are done.
Yes, sir, we are done with all the papers
Okay,
that we have now.
Okay, that's fine. That's fine. No issue. No issue. Yeah. Varsha madam, do you want to share some views?
Yes, the presentations are very nice. Implementation is also done very nicely, and yes, it is effectively. And all the two researchers, they have actually implemented it live. It was really very nice.
Yeah, Anisha madam.
Yes, sir.
Yeah. Maybe we can take a group photo.
Okay, so we are done with all the papers, and I sincerely thank all the presenters for their excellent presentation and contribution in this session, and all the participants for being a part of this World Conference. We, on behalf of the whole team, thank you for your support during this version, and we will be happy to have you in the second version in 2023. All the presenters would be getting their digital certificates through email within 2 to 3 working days. And further, all the papers have already forwarded to Springer. The publication will be live within 6 months, so kindly cooperate with the team of ISBM. And I would also like to thank our session chair for chairing this session. Just a second. Here is a small token of appreciation on behalf of the team of ISBM and Global Knowledge Research Foundation.
Thank you.
So,
I like the
Parikshit and
Good.
Mahale, and to Professor Varsha Damodar Jadhav.
Thank you. Thank you very much.
Thank you both for your valuable presence in the session.
Thank you. Thank you very
Thank
much,
you.
Anisha ma'am. It was
Thank
really
you.
very nice having you. And yes, I would also like to thank the director, that is Mr. Amit, Dr. Amit Joshi, Professor Mahale also. We are working in the same department, and everyone, and also inviting me as a session chair. Thank you very much.
Thank you, team. Thank you. Thank you, team ISBM.
Sir, I think we have another presenter who have just joined.
Okay.
The presenter name is A. Bal Subramanian, and the paper title is Promoting Network Connectivity in a Textile Showroom. Dear presenter, you can please start your presentation.
Thank you. Just a second. Let me share my screen.
Sure.
Okay, whether my screen is visible?
Yes, it is visible. Please go ahead.
Yeah. Thank you. My name is Dr. Balasubramanian. I'm working as an assistant professor in the Department of Mass Communication at Amrita Vishwavidyalaya, Coimbatore, India. Okay, the title is all about promoting network connectivity in a textile showroom. So let me introduce the concept of the social network analysis first. So social network analysis is a kind of a one particular tool, and we use this tool to convert the data into graph format, and we understand the pattern of the relationship, and then we go for the analysis for that. So this will help us to identify a lot of interesting aspects and invisible components. So any isolate vertex, which means a person who any point is not connected in the graph, which you technically call as an isolated vertices in the network, is a serious problems. For that, we are supposed to pay attention. We need to address that issue. So finding the reason for an actor to be an isolated vertices and steps to be taken for making the persons to interact with the other members of the network are really important. Otherwise, what will happen is the entire communication flow will get affected. So this social network analysis can also be used to identify a bottleneck element, which means the person who is the responsible for disturbing the smooth function of an organization. I would like to take a kind of a one small example, which was mentioned in a book called Hidden Power of Social Network, the book which was published by Harvard University Press. So what they said that in an organization, they hired the best people for a project. And there's a kind of a two dominant groups. Both the groups are really good in their areas, but the progress is not that much great. So the institutions, they couldn't able to figure it out where it went wrong, why there is a problem, something like that. So finally, a mathematician, technically a graph theorist. He said, okay, fine, let me identify where it went wrong. So he got the data. He studied the network pattern of the entire employee in that particular organizations. And he identified that two people who are actually acting as a kind of a central point of contacts. Like for example, A is one group, B is another group. A person in A, probably A5, A1, A2 as a kind of a the people in that particular group. A5 and B7, they coordinate the entire network in that particular sector A and B. So what will happen if I'm part of A group, instead of me asking with A7, the A5 will say, boss, tell me, let me get whatever information you require. Because he want to claim that he is the master brain behind the entire team A and the other person in team B. So because of this, what happened is people start depending on that one particular character for every information. So this affects the flow. And if the person is not able to understand exactly, he may slightly modify based on his own understanding. He presented it to the people. So people got some kind of a problem and the process got delayed like anything. So now the graph theorist, he converted the entire situation, entire network into a graph format, and he identified the bottleneck element that A5 and B6. So he gave a one simple recommendation. He said, promote both the people to two different projects. Leave it enough. So after a period of 3 to 6 months, so the other people are now forced to interact with the other set of peoples. So now the connections within that particular network is so good, and everybody knew about the strength and weakness of their co-workers. So because of that, the progress, okay, is a kind of a drastic improvement in the progress. So this is one simple case study which was presented by in the book, The Hidden Power of Social Network. So when we take any organization, if there is more than 5-10 people, obviously there will be some kind of a problem. So we encountered a similar kind of a situation in our study of the functioning of a textile showroom in Tamil Nadu. So let me give a kind of a small overview about the organization. This is a textile showroom. They do have some 5-6 branches in around Tamil Nadu. And the branch which we took it for the study is in one particular location in Tamil Nadu. So there are around 3 managers who are in charge of various sectors in the showroom, and they are denoted as M1, M2, and M3 for the coding purpose. So the designation of M1, the manager 1, he is the production or product in charge, but he also take care of the entire showroom. The second manager, who is the floor in charge, he also works as a supervisor as well as assisting the M1. And the manager 3, he is a kind of a overall in charge. He was recently promoted at that time. He was a promoter from some other chain of their showroom, because some problem in this organization, even though the other showrooms are doing really a good business, only in this particular showroom there is a problem, because the product are same, the pricing are same, they do have a very good reputations. Except this showroom, in every showrooms there the marketing, the sales, the profit, everything is so good, and the customer review is also really good, but only problem in this particular showroom. So they promoted a person from another showroom to this particular showroom as a kind of one of the in charge, and try to understand where it went wrong. So all the managers are coded as M1, M2, and M3. And the salespersons are denoted as S1, S2, up to S27, which means there are 27 salespeople are working in this particular organization. So the management, they are not able to understand where it went wrong, the similar kind of a problem. And they approached us. So we had a kind of a, this is myself with my students, we had a kind of a discussions with the showroom in charge, and sorry, the proprietors. And we tried to understand the basic things. And then we came up with the 4 questions. So we asked to each and every employee in the particular showrooms, the managers as well as the showroom, the sales persons. The question number one, if you face any problem while you are carrying out your work in the shop, from whom will you seek help? The second one is when you have new ideas or suggestions for improving the performance of the shop, with whom will you share and discuss it further? The third one, if someone working with you goes on leave, you may find it difficult to carry out your regular work. Give the list of such persons. And the fourth one, give the list of persons in your shop with whom you have regular communication. The reason why we came up with the four questions is to understand about the dynamics of the network in the showroom. So the questions may look like, okay, what is a big deal? Okay, I'm just going to communicate something with a person X or a person Y. But when we convert the answers into a graph form, it is going to provide us a kind of a lot of avenues to explore where it went from. So after we got the data, it's here we all the employees are asked to give their co-workers name. So everybody who was working in that institution, they provided the data. So 27 plus 3, 30 samples we got it. And we coded it in the software called Pajik, P-A-J-E-K. So that software which we use to convert the entire data into a graph format. So this one is the graph for the first one. So the first question is, for any problem in your work, whom do you seek help? Now, when you see that almost everybody except S15 and S25, which means the salesperson 15 and salesperson 25, the others are in touch only with the managers 1 and 2, the showroom in charge as well as a floor manager. Right. Now, when it comes to the Q2, the Q2 is any idea or a suggestions. So generally in any kind of an organizations or any networks, if I do have like some suggestions, before me discussing it with the higher officials, I generally try to interact with my co-workers, try to understand whether my point makes sense. Am I making sense? Am I approaching it in the right direction? And I may get their opinions, their views, then I'll decide whether can I take it to the higher officials level. But what happened here is, again, the discussion with the co-workers are bare minimum, and whatever it is, these people, they are only interacting with the manager 1 and 2. So when we converted the first two questions into a graph format, there is something wrong with M1 and M2, and we calculated something called in degree, which means how many people they are approaching the character M1 and how many people the character approach is called as an out degree. So what is the in degree and what is the out degree? So M1 gets most in degree followed by M2. So M2 is in touch with M1 for so many things, but M1 in turn is not discussing anything great with M2. So in these questions and all, this guy is not discussing anything with M2. So this gives a kind of an idea to us that M1 is dominating the entire thing with the support of M2. Now, when we convert to the third question, so the third question, it's like if someone is on leave. So generally, if some of our colleagues takes leave, we may get an extra work. So so we would like to identify that particular pattern. And here we can see, and again, everything is connected with their own departments. So the top right area, that is one section. The left, a huge network, is a kind of a ladies wing, and the another one is a gents wing. So this gives a kind of an idea. Okay, people are forced to work only with their one particular department, and they just discuss only maybe interacted only with them, or if any of those person is on leave, this guy or girl is forced to uh, do a kind of an extra care for that particular department. So this gave a kind of an idea to us that okay, people are not moving to any other floor; they're just sticking with one floor with one department. And the fourth one, this is a really interesting one. So the question four is the person in your shop with whom you have a regular communication. See, there are so many people who are isolated. For example, S26 manager 3, interestingly, S11, 12, 25, 27, S28. In a small organization with a manpower of 30, what is the need of around 6, 7 people are isolated? And we can see another two small things like S1 and S16 are interconnected with each other, which means they are communicating only with those two people within them. Similarly, S7 and S10. And the manager 2, the manager 1, they are in touch with each other. And S24 is a guy who is in charge for the godown area. And hence he is also in touch with these things. And manager 3 is isolated. So after seeing this graph, we found something wrong with the top level area, managers level area. So we had a kind of a observation, try to understand the body language and the behaviors of the other workers. And based on that, we gave a kind of a few recommendations to the proprietor or the owner. So we said that the manager M1 is a bottleneck element in the showroom and he is blocking the overall communication. And the manager 2 is also supporting the manager 1, has joined hands with him and is also supporting the process of blocking the communication. So we gave a kind of a recommendation, either you remove manager 1 or probably you can give a kind of a serious warning and put him under the radar. And M2 should be continuously observation. If you want, you can also remove or keep them in the observation thing. If M1 is removed, then we gave a kind of a recommendation to promote M3 as an overall in charge for the entire show. And we also added a couple of more additional recommendations to. One is about the proprietors of the company should regularly visit the showroom and monitor the in charge and also communicate with the employees. Employees should be encouraged to have an interpersonal communication with the opposite genders, which will develop positive work culture, because from the graph 4, we can able to understand that so many people are isolated from the entire network. And could be a kind of a one training sessions or a 1-day camp should be conducted in a regular interval to educate the employees about the products in the show. Because for everything, these people are forced to dependent on M1 and M2. So for example, if I go as a kind of a customer and if I ask any kind of a doubt related with one particular product, if they say that I don't know, better you let us get it from one particular person. For everything, if they are pointing out only one person, as a customer, I feel okay, this guy is okay, the showroom, I'm not liking it. So that is what exactly happened there. And in case of any small additional information, these people, they don't know whom to approach because they don't have a proper interpersonal communication with their co-workers. So we said that we should encourage them, and as well as a training sessions about all the products. So if anybody asks any kind of a doubt, the people can able to clarify it then. And shuffling of the workers regularly between the section in the organization should be done periodically. This will help those people to understand about the various products or the materials available in that particular showroom. So this will ensure that the salesperson will become familiar with products of all the sections. So when we gave these suggestions to the proprietors, they're hesitant in the initial. They said that we know this manager 1 and 2, those people are with us for a longer period of time. We know them properly. They said that there are some methodological issues in the research. Something went wrong. We are not happy with that one. We said, okay, this is what the research says. We said it is applicable. But these people start monitoring those people, and after some point of time, they really understood that yes, M1 is a problematic person. So whatever we gave as a recommendation, they implemented it. So M1 was removed from the showroom, and M2 was appointed as an overall in charge for that room. And the serious warning was given to M2 because due to some personal thing, his wife she gave a birth to a baby. So in that earlier childhood period, they don't want to disturb the smooth functioning of the family, and hence he was given with a serious warning. And then the proprietors start visiting the showroom and interacted with the employees in an informal manner. It's build a kind of a very good rapport between the employer and the employee. So after 3 months, the work culture of the showroom and the feedback from both customers and employee have given more positive results. Buyer satisfaction, seller satisfaction is achieved. The sales rate has also increased. This is what the major problem for them. So because of that, the showroom people, they gave us a testimonial. So I deliberately added the brand name. So they said that recently we faced some problem in the smooth functioning of our organization, which also hit us financially. Though we could identify that it was somehow related to the flow of communication and affecting the chain of command, we could neither identify the exact nature of the problem nor the source of the problem. It was in these circumstances that services from us, my team, was utilized. The team, through their delegate work and expertise in the field of network analysis, could identify the exact nature of the problem and also pinpoint the source of the problem. They also came up with a solution and list of practical suggestions for improving the functioning of our organization. So we implemented the suggestions and recommendations provided by them, and the results were favorable within 3 months. We would like to congratulate the team and convey our gratitude for helping us at the time of our need. Wishing you the very best in their lives. And this is one of the partner of this particular showroom. He gave the testimonial to us. So application-based approach, especially applying graph theoretical component for any unnoticed or invisible component in the network, we can able to tap it. So the moment when we identify the bottleneck element and understood the root cause of the problem, it is possible for us to provide a solution. This is what actually we did it in this real life situation. So thank you all. This is all about the paper.
Yes, hello.
Yes.
Hello, Dr. Balasubramaniam. Very good afternoon.
Yes, good afternoon.
Your research is really very, very interesting.
Thank you.
And you have presented it very nicely. And I would like to know what methodology was used for implementing the project.
Ma'am, it is not a social network analysis itself is a kind of a method.
So is are the concept of egocentric?
It is not a
egocentric network
one.
for social network.
In network analysis, we can look about various aspects. What you said is one angle. Okay, but for this particular showroom part, it is not a egocentric. It is connected with the power politics. The power. Okay, who is going to get the hold the major power? So the method, the network analysis will help us to identify the invisible pattern. So that is the power of the network analysis. Probably I can say this itself as a kind of a methodology, because it's a combination of both quantitative and qualitative.
Okay.
Because we gave 4 questions, we asked the people to provide their co-worker's name. So questionnaire method, we applied it. It is not just only about the questionnaire method. We also did a kind of a observation. we had a kind of an intensive interviews with the proprietors to understand the issue first. So it's a mixed method approach, but we use the network analysis as a prominent method to analyze.
Also, I would like to know the reason that the answers to the 4 questions. Hello.
Yes, ma'am. Go ahead.
Yes, yes. Also, I would like to know the reason that the answers to the 4 questions are showed using a graph. What
Yes,
was the reason to choose a undirected graph there?
Ma'am, it is we try to understand about the kind of a network only. So if someone is interacting, for example, if you are interacting with me, there is a kind of a interpersonal communication happening between me and you. It could be a kind of a directed graph or it could be an undirected graph, but somehow we are in connect with each other. So here I just want to know about the connections between and within the people. So that will help us. Okay, if someone is isolated in both the way, for example, if I'm looking only about the directed graph, okay, if someone probably in connect with someone, and uh, we can't come to a kind of a conclusion because someone is not interpersonally communicating. That doesn't mean that he's not communicating exactly. The body language itself is a kind of a communication aspect. So that is why we went with the undirected or yes, ma'am. Am I audible?
Yes, yes, yes. You're audible. Yeah, yeah. Thank you. Thank you very much. It was really interesting. Thank you,
ma'am.
That's from my side.
Yeah.
Sir.
Yeah, Professor, can you hear me? Professor Balasubramaniam?
Yes, sir, I can hear you,
Yeah,
sir.
yeah, very nice work and very well presented.
Thank you, sir.
I want, can you please go to that questions, data collection slide?
Sure. 1 second, sir. Yeah.
Yeah, so my first, I would like to know, these 4 questions you have framed, and then how did you collect this entire data? You have prepared the Google form and collected the responses. Is it like that?
No, not a Google
No.
form thing. So this questions, as I said, we got a one very good book, Hidden Power of Social Network, which was published by the Harvard University. They gave us certain guidelines. So the questions may be very, it depends upon the situation.
Right. So
Right.
that's what my question was. How will
exactly.
you?
That is why I'll clarify one. So the same pattern, we also tried it in the different occasions. So I just want to understand about my own students' network. So instead of asking me about the improving the performance and all, I may ask, okay, for a small financial support, whom do you approach? Right. So for every situation, the researchers, the authors, they gave a kind of a beautiful guidelines. So only thing is we need to understand it. So the Google form thing won't work here. So what we did it, we personally went, one of my students, she went to that particular showroom,
And
gave
then
a paper to each and everyone till we told them only one thing. So this is what the question is all about, because some of the people, they don't read English. So we translated in our vernacular language. So the question was explained and we asked them to write only the names.
Right. Okay, I have another question. So as you mentioned that, depending on the situation, this question would vary, right?
Yes, sir.
Then what is the mechanism to ensure that we have set the right question?
That is why I told you, no, sir, the book gave us a kind of a proper guidelines.
No, book is fine, but if suppose, this is something to be extended and suppose we don't have access to the book, then is there any other alternative mechanism for that?
Now there are a couple of articles are also available. There are a lot of case studies are available. The same concept can be applied in various situations. So a couple of research papers are available right now, and there are a lot of books are available. If not about the hidden power of social network, there are so many books are available related to the social network analysis. So if we had understood the core concept and understood the issues, sometimes we ourselves can come up with our own questions. It's based on the nature of the problem. So for us, understanding the problem is more important than anything else here.
Yeah. Good work. So you are working in mass communication department, right? So how you are
Yes.
then, who will be the stakeholder? What you are looking for? Who will be using that? Once it is this entire
So
research
this
over.
this this method we can apply it in any context. For example, let me ask you one simple question. If you get a fever, what tablet you take?
Right. Proceed.
Generally, you
So
took paracetamol,
paracetamol or proceed. Yeah. Yeah.
right? Yeah. So for your running nose,
Yeah. Cetirizine maybe something. So standard some guideline.
standard thing. It's mostly everything comes headache, everything connected with the paracetamol,
Yeah.
right? So for every reason we are taking a paracetamol, what will happen to us? When we get a
Yeah.
kind of a side effect,
Right.
okay, we are getting a fever because of one particular body cell got infected. So that cell is isolated from the entire network.
Yeah.
Right now, what I can do is we already proposed it actually to the pharmaceutical research people. They immediately rejected. They said we don't want to spoil our business.
True.
So, to be
True.
frank.
True.
So what we recommended to them is, so take the blood sample,
Hmm.
understand the network of all molecules.
Yeah. Yeah.
Right. For headache, okay, one particular cell got infected, which means automatically it is isolated from the network. Now I just need to give medicine only to that particular cell to ensure that it is get into the network pattern. So we can think about a customized drug design, which
Right.
automatically eliminates the side effect.
Agree.
Right.
Perfect. Yeah,
So
I got
the
it. Good
same
work.
thing
Yeah.
can be applicable in any context.
Yeah. Clear. Thank you. Good work.
Thank you, sir.
Thank you so much.
Thank you for your presentation.
Thank you, ma'am.
And
Sorry, I didn't notice that my video was in the mute mode. Sorry.
no issues. Moving further, I would like to invite our next presenter, Taslima Noor, to present her paper on the title, A Review on Twitter Data Sentiment Analysis Related to COVID-19. Dear presenter, you may please start your presentation.
Sure, thank you. Hello everyone. My name is Taslima Noor and I will be presenting the paper, A Review on Twitter Data Sentiment Analysis Related to COVID-19. So coming to the introduction, we know that the term pandemic refers to a disease that spreads rapidly and engulfs an entire geographic region. Coronavirus is a brand new viral disease named after the year it first appeared. There is a scarcity of academic research on the subject to help researchers. Social media content analysis can reveal a lot concerning the general temperament and mood of the human race. In the field of sentiment analysis, deep learning models have been widely used. Sentiment analysis is a set of techniques, tools, and methods for detecting and extracting information. Folks have already used Twitter to share data about the COVID-19 pandemic. The numerous studies surveyed are selected based on a similarity. Every paper which is supervised performs sentiment analysis of Twitter data. Various studies have made use of a fusion of diverse word embeddings with either machine learning classifiers or deep learning classifiers. Albeit the interpretation of single classifiers is satisfactory, the studies those proposed hybrid models have shown outstanding performance. On top of that, transformer models demonstrated quality results. It is concluded that using hybrid classifiers on Twitter data for sentiment analysis can surpass the achievement of single classifiers. So in this survey, we have surveyed around 30 papers that are related to Twitter data, NLP, machine learning, deep learning, and transformer-based models. So as we are time bounded, the title and publishing date and the authors of the papers have been mentioned at the end of the slide, and I'll be discussing what the purpose of the papers was, what is the data set they have used, and the labels they have taken, the methodology, classifiers used, and the evaluation metrics with the results. So coming to the paper, to this paper currently you are able to view on the screen, the authors wanted to evaluate the performance of benchmark datasets and provide benchmark results. The dataset used has been extracted using Python Twitter API with 2.1 million tweets crawled from February to March 2020, and it includes 90,000 unique tweets, and all of them are English tweets. The labels are positive, negative, and neutral, which have been labeled using text block tool. For feature extraction techniques, they have used 4 different type of techniques, that is TF-IDF, word-to-vec, glove, and fastx. The classifiers used are SVM, random forest, navy Bayes, decision tree, bile SVM, with word-to-vec and glove, and another one with glove plus CNN. The transformer models used are Distilbert, BERT, ExcelNet, and Albert. Evaluation metrics used are accuracy, and from the results we can see that the transformer model, that is BERT, has given approximately 94.8% accuracy. The second paper is, it understands, the authors wanted to understand the sentiment of the customers of an airline by using the SMO algorithm, that is sequential minimal optimization. The dataset used is airline Twitter dataset, which has been sourced from an API. The labels again are positive, negative, and neutral, and the proposed methodology is SMO with a decision tree, that is a hybrid classifier. The classifiers that have been used for the comparison purpose are KNN SVM, then a hybrid classifier of KNN SVM, single SMO, then decision tree, and the proposed methodology. The evaluation metrics are accuracy, precision, recall, and measure. The results show that the proposed methodology has been able to achieve 89.47% accuracy, 91.6 precision, 89.5 recall, and 96.3% of F measure. Remaining, although classifiers were able to achieve an accuracy ranging from 67% to 80%. Next, these authors' purpose was to show the progress of fear sentiments from the COVID virus when the COVID virus kept arising. The dataset used has been extracted using the R language, using the R tweet package, which by which they were able to extract 900,000 tweets using the corona keyword. After the pre-processing, they have labeled the data as positive and negative using the R sentiment packages. They have, in the methodology, they have done a tremendous job in textual analytics by performing an EDA. The classifiers used are Navy Bayes and logistic regression. From the results, we can see that Navy Bayes, when the number of tweets were less than 77, the accuracy was 91.43, and when tweets were less than 120, it was 57.14. Clearly, Navy Bayes has shown better results. And the limitations of this paper is Navy Bayes and logistic classification for short to medium length tweets have given good accuracies, but when the length of the tweet has increased, the accuracy has tremendously decreased. The next paper. The authors wanted to propose a database which, by using the already present dataset naming COVID-19 tweets dataset, they wanted to obtain geo COVID-19 tweets by filtering out the geo tag tweets. The data they have the data set they were able to extract had English language tweets and their sentiment scores as positive, negative, and neutral. The at final, they were able to extract this geo COVID-19 tweets, and for EDA purpose, they have used multiple visualizations and charts to show their geo version, and the results are region-specific maps and top hashtags have been extracted. The next paper, the authors aim to propose a hybrid deep learning for sentiment analysis. The dataset collected was STEM Eval 2017 dataset. The labels are highly positive, neutral, negative, and highly negative. They have annotated these labels using Crowdflower. The methodology used is after collecting the data and pre-processing the data using NLTK library, they have applied the proposed hybrid model that is HDL-SA/ANN, that is hybrid deep learning for sentiment analysis using artificial neural network. Also obtained visualizations of the time taken by each model for the analysis. The classifiers used are decision tree, random forest, naive, and artificial neural network. From the evaluation metrics are accuracy, precision, recall, and F-scores. From the results, we can see that the proposed hybrid model, that is artificial neural network, was able to pull out an accuracy of 92%. The purpose, coming up to the next paper, the purpose of this paper was to analyze the stock price movement by three major airline companies and to understand the stock market during a pandemic. For the data collection, 10 official Twitter handles, namely the ones from American Airlines, Delta Airlines, United Airlines, Yahoo Finance, Financial Times, CNBC, CNN, MSNBC, NBC News, and Fox News are selected. A sample of 30,000 tweets are passed, analyzed the topics related to general, travel, and COVID. The model used is ARMA and GARCH. ARMA as a mean model and GARCH as a variance model. The evaluation metrics are MSE, MAE loss, and Q-like loss. The results are higher level of volatility in the stock price index of three of the biggest airline companies from the USA, and that can be explained by the internet concern on the relative topics related to the pandemic. The next paper. The authors here wanted to propose a machine learning based approach to detect dengue and flu outbreaks in social media platform Twitter. So the data set collected is the benchmark data set on dengue and flu labeled 6,000 tweets, infected or non-infected. This is an already available data set. The labels are positive and negative. For feature selection, they have used TF-IDF. For the classifiers, they have used random forest, KNN, ISBM, and decision tree. The evaluation metrics are accuracy, precision, recall, FN measure, and ROC curve. The best results are obtained by random forest classifier. The next paper. The authors here wanted to analyze tweets by Indian netizens during the COVID-19 lockdown. The dataset collection was 3,090 tweets collected on the dates between 23 March 2020 and 15 July 2020. The labels are fear, sad, anger, and joy. TF-IDF is used for feature selection, and the keyword analysis has been performed in the study. Logistic regression, SVM, LSTM, and BERT are the models used in the study. Accuracy is the evaluation metric, and the highest accuracy was able to achieve if by BERT with 89%. Next paper. Here the authors aim to test the reliability of several hybrid techniques on various datasets of different domains. The datasets used are Sentiment 140, Tweet Airline, and Tweet Semval, and 5 datasets contains reviews: IMDb Movie Review 1, then IMDb's movie reviews 2, Corner Movies review, book reviews, and music reviews. These are total of 8 data sets they have analyzed. All of the data sets have positive and negative, while Sentiment 140 and Tweet Thailand had positive, negative, and neutral. So the authors decided to uh, just consider positive and negative from those two data sets. Methodology used is BERT and word2vec for feature vector to build a feature vector, and the classifiers used are LSTM, CNN, SVM, and a hybrid model, LSTM with CNN with SVM. Then the another one was LSTM, CNN with ReLU. Evaluation metrics are reliability and computation time, accuracy, AUC, precision recall, and F-code. Obviously, as stated, the hybrid classifiers outperformed with high accuracy, mostly more than 90% for all the data sets. Coming up next, the authors here wanted to design a hybrid model for sentiment analysis during pandemic. For the data collection, the keywords used were COVID-19, coronavirus deaths, new case, and recovered. The labels are positive, negative, and neutral. They have used R packages to do so. R language is used for the entire implementation, and analysis is done using 20, 50, and 600 tweets for the comparative analysis. Against SVM and RNN, most frequently used results are also extracted. Then hybrid heterogeneous support vector machine, that is the proposed model by the authors. Precision recall, F1 score, and accuracy with RNN and SVM are the evaluation metrics. HSVM scored and accuracy greater than 95%. The next paper here, the authors wanted to help the government in analyzing their responses. The data gathered on the screen, sorry. Yeah, the data gathered on the sentiments of Filipinos regarding the Philippine government's efforts using Twitter. The RN search Twitter operator was used to search for tweets, particularly in the Philippines with the language English and Tagalog. Positive, negative, and neutral tweets with using rapid minor was labeled. After the pre-processing, EDA is performed to extract word clouds and graphical representations of the label. And the classifier used is Navy-based, which was able to achieve 81.77% accuracy. Coming up next, these authors wanted to identify vaccine hesitancy opinions of great importance, as the refusal of to take COVID-19 vaccines is concerning from public health point of view. The data set collected is 4 million tweets within the time range of January 2022 to January 2021. That makes an year. Positive and negative tweets are labeled using Radar tool. Frequent hashtags and mentions, keywords, and themes have been explained thoroughly using the data visuals in the paper. The results or the conclusion they have come up with, positive sentiments about the COVID-19 vaccine was the dominant popularity. Vaccine rejection and hesitancy was more than interest in vaccines. Next, these authors wanted to analyze the Indians' perception of what causes stress, anxiety, and trauma during COVID-19. The data set collected was consists of 8,40,000 tweets from April 1 to October 30. The labels are positive, negative, and neutral. They have used LDA for topic modeling, that is latent dirichlet allocation. Then the results are sentiment analysis study revealed the interesting fact that even while discussing about the stress, anxiety, and trauma caused by COVID-19, most tweets were in neutral sentiments. Death and lockdown caused by the COVID-19 were the two most important aspects that caused stress, anxiety, and trauma among the Indian citizens. Here, the authors wanted to understand and analyze public sentiment towards social distancing as articulated in Twitter textual data. The data was collected using the Twitter API, and SentiStrength tool was used to label the data as positive, negative, and neutral. Filter tweets with user location as Canada, and then the tweet text with social distancing keyword. The classifier used is SVM, confusion matrix, precision recall, and F-score measures are the evaluation metrics, and the result obtained from this classifier is 75% accuracy with 80 to 20% training and testing split, 81% accuracy when only positive and negative tweets are considered, 87% accuracy when 10% test data is increased. Next up, these authors wanted to predict COVID-19. So they have used X-ray images data set from Kaggle. The labels were normal and pneumonia.
Sorry for the interruption, but you have only 1 minute left. Please conclude your presentation as we are running out of time.
Sure. This is the last but one slide. I'll just finish it up fast.
Yes, and also your screen is stuck.
Oh, okay.
We cannot see your presentation.
Is it visible now?
She is moving,
Okay.
Anisha madam, she is moving.
Okay, yes. So, yes, okay, sorry.
Sure. The classifiers used are CNN, VGG16, and VGG19. From this paper, they have concluded that the baseline classifiers were able to achieve 93.95% accuracy, and the best one was the best accuracy was able to get using the multi-class classification. Here the authors wanted to propose an SNS big data analysis framework for COVID-19 outbreak prediction in smart, sustainable, healthy city where Twitter platform is adopted. Around 10,000 tweets were used and pre-processing was done and the labeling was done as confirmed and non-confirmed. TF-IDF is used for feature extraction and 98.9% accuracy was obtained. In this, the authors proposed a hybrid model to analyze the sentiments of the consumers, and the data sets used are airline equality, airline sentiment data, and Twitter airline sentiment data, positive and negative labels, and the classifiers used are logistic regression, decision tree, SVM, Navy base, CNN, LSTM, and a hybrid model. Even in this paper, hybrid model was able to achieve the highest accuracy. The authors aim to investigate how public sentiments respond to the pandemic from March 2 to March 21. And here also, the CNN and LSTM was able to get a higher, a good amount, the best analysis. Here, the authors have aimed to propose early detection of the fake news on social media. TF, IDF, and Glove has been used as feature selection. Machine learning classifiers have been used, and the proposed model was able to pull up to 99.78% accuracy. The authors here wanted to understand and unravel people's sentiments using deep learning techniques, and the highest accuracy obtained was from LSTM 90.59% and from BiLSTM 90.83%. So in conclusion, this study involves diversified works of several authors related to COVID-19 and Twitter data. Twitter data is deemed as one of the most utilized source of data collection for such type of analysis. All the papers surveyed here are using hybrid models or stacked models, and they were able to conquer the highest accuracy score when compared to the single classifiers for sentiment analysis. The results achieved from hybrid classifiers are outstanding. The usage of combination of various classifiers with different word embeddings have proved to be a good course of action and exploratory analysis. Thank you, everyone.
Yeah, can you hear me?
Yes, sir.
So in this entire paper, what is your contribution? You have done just the survey?
Yes, sir. This is a survey. As I'm a
Okay.
PG scholar, I will be using this survey for my next paper.
So what is one major finding from this survey? What do you think that what is missing?
The thing missing here is many of the papers have not worked with multiple word embeddings, multiple feature selection, uh, with hybrid classifiers. Either they have proposed one single one single hybrid classifier with one feature selection technique. They have not used multiple feature selections.
Okay, fine. Thank you.
Yes, yes, Taslima.
Yes, ma'am.
Yes, now all these review papers, they are showing you many different kinds of methodologies used
Yes,
there.
yes, ma'am.
So in your future work, what methodology would you like to use and why?
In my future work, I want to use multiple feature extracting techniques, just not one, and don't want to limit my work just to TF-IDF. I want to use the TF-IDF, glove, then we have other features, feature selections like word to vex, then FastTech, and even one word embeddings. There are multiple versions of these embeddings, like we have 200 dimensions, 300 dimensions, and similarly we have different word embeddings for Twitter data separately. So I intend to use those kind of feature extraction techniques for my methodology.
So you would like to work with text data here?
Yes.
Have you thought of any processing techniques which will filter your data?
Yes, while collecting the data itself, I have filtered out using a few filters. Like I wanted to work with English reads, I have filtered out while collecting the data itself. Uh, oh, I have just constricted to English reads, or constricted myself to collect the data from so and so date.
Okay, fine. Thank you.
Thank you, ma'am.
Thank you, Taslima, for your great presentation.
Thank you so much.
And moving further, I would like to invite our next presenter, Prasad N, to present his paper on the title, Analysis of Crop Yield Prediction Using Random Forest Regression Model. Dear presenter, you may please start your presentation.
Thanks for the invite. Yeah, good evening to everyone present here. So I'd like to present my paper on the title, Analysis of Crop Yield Prediction Using Random Forest Regression Model. I hope my voice is audible.
Yes, it is. Please go ahead.
Yeah, okay. So the content which I'm going to cover in here is the abstract part, introduction, literature survey, the objective, proposed architecture, methodology, and the discussion of results. So to start with, so we know that the agriculture sector is one of the most important application areas in India. So where we could find multiple hurdles in implementing and finally getting the end results. So this involves multiple decision making situations sometimes, and it is very complex also to address those problems. So in this scenario, we go for implementing some machine learning techniques. So which will help us to yield the better result in terms of production. So this is what the main objective of this research work. And to start with, it is proposed to, it is decided to have three different algorithms has been considered initially, like density regression algorithm, gradient booster, and random forest algorithm. All these are supervised learning machine algorithms. So this has been considered for our analysis. And after implementation, we could find out that this model predicts there is especially this random forest gave up, made up with a good result, and it gave up with an accuracy of 89% prediction result. And so this is what the main introduction of this method. And the objective for this research is carried out. So to determine the yield prediction of selected crops from all the states in India. So based upon different seasons. So how far we could get the better yield and what is the current yield ratio, so that we could find out the gap between these two, and we'll try to find out the better solution, how this could be bridge the gap between these things. Okay, so for that we go for this. So these yield prediction can be done by analyzing the information gathered from the government websites. So I'll show you the database from which I collected, and based upon that, we analyze the meteorological data, the agricultural statistics, which is provided by the government of India. So, and to this base work, we have done some literature on this already published works. So where we could find some of the, I was listed out some of the 7 works which has been already which I referred to, or it has been already something published, where they used most of the algorithm which I am considering right now. Like I said, for the decision tree, they talked about their progression. I talked about random forest. All these are is again considered. So just for an initial study, we have considered this paper and started implementing. And the architecture of this model is start with the data collection, and the next one would be the cleaning the data and transformation and data transformation. So after that, we go for analysis of data and regression analysis. Finally, the end result of the model. So that will be concluded. Moving forward to the next one regarding the random forest regression. So we know about the random forest regression. So it is a model in which the data sets divided into different subsets. Okay, rather of having it as a whole, we divide into a different subset in which the decision tree algorithm is applied. At the end, the average is taken to improve the predicting accuracy of that particular data set. So why we go for this? Even when there is some missing data, all these could be discarded, and in overall, we will get a better result. So for that reason, we basically go for this kind of random forest regression method. And this is the flow of algorithm, random forest algorithm, which has been given in steps. As I already said, we divide into k subsets, and based upon that, the decision is applied to the selected subsets, and then a prediction is made on each decision tree. And this will be iterated for all the divided k subsets based upon the data available. And the average prediction of this subset will be our final predicted value. So based upon this algorithm, our algorithmic the crop prediction is going to be evaluated. And this is the diagram, whichever I said you. So we'll have test data and training data. So the training data will be divided into subgroups, and it will be decisions will be given. Finally, averaging of all the decisions will be gathered, and finally we come up with the predicted data. And this is the website from which I have collected the data set for the crop prediction. So this data set consists of 9 agricultural features. So like a few parameters like temperature, rainfall, okay, and then the area in terms of the consumption agriculture area, season, crop, there is crop production, pH value, the nitrogen value, and electrical conductivity. So these are some of the features that this data set consists of. So there's a sample data set, screenshot, which is I'm showing you here for your understanding. So as I said, you on some different headers like area, production, rainfall, season, temperature, crop, pH, nitrogen value, and electrical conductivity. So these are the few snips of the screenshot. And coming to the operational part of this crop prediction. So as we first stated in the architectural diagram, cleaning of data. So the data is cleaned for missing values, for first analyzing the frequency of missing or null values. So that will be identified, and then all those would be dropped out from our data set. So just I have added a slim screenshot of the working of our project. So where we could find on the first half, we could find out there is an dip in there is a rainfall of 54 missing data, and further it has been eliminated. So where we could find now 0 in our result. So and then the next one would be the data transformation. So here like a few features that we consider like season and crop name or in terms of a categorical values. So it is very difficult for us to process. So what we do with the help of an encoder, what that has been transformed into a discrete values. So as shown in this diagram or the screenshot. So here we have, if you could see the rain, sorry, the season, which is in form of it is before data transformation. And the next screenshot will show you we have some unique values given for the seasons as well as for the crop, the crop values. You could see some numberings for the unique numberings for the crop has been given, so that based upon that the data transformation is quite easier for us to carry out. So it has been done here at this stage, and the analysis of data. So this analysis is done by finding the correlation among the features of the distributed data which has been available. And to do or to carry out this, we work with the Python libraries, like namely like matplot and seaborn is something is used for analyzing this data. And a few of the analysis has been shown as the screenshots of our outcome. So this is the predicted results based upon the season versus the quantity of production with respect to of crops. So where if you find the best upon the season, like there are various seasons with respect to the productivity of the crops has been shown here is one analysis. So the next analysis would be the predicted results is based upon the yield for a selected crops of an year. So there are a variety of crop has been considered, but here for an output, I have selected very few crops, and all these crops, how much it yields for an year, it has been considered, and it is shown as the final result here. And the next one is the production yield based on the seasons. So what we consider the different crops and what are the crops that it produces based upon the different season in a year. So there has been the third analysis, which has been considered as an initial stage. The next, this result showing the amount of rainfall during each season. So we have various seasons in every year. So based upon with respect to the different season, what is the amount of rainfall? So that has been shown as a graph diagram here. And finally, to end up with the result part, that is we use an R squared value. So this will help you to find out the result. That is the error fitting out of error. What is the next result we are going to obtain? So if you could see here, so this is the performance of a random forest algorithm. As I already said you earlier, we are compared with the three different algorithm. One is with random forest algorithm, and it's end up with the R square value of 0.895. And the next one is would be with the performance of decision tree algorithm. So where we have an R square value of 0.848. And the third one would be the performance of the gradient boosting algorithm. Okay, where we have an R square value of 0.883. So by comparing all these three, we could easily conclude that this random forest algorithm is produces the outperforms well. It is closely approximately equal to 90% is our result with respect to comparing to these three results. So as it is since it is an preliminary work, I have concluded my research up to this level, and this has been plotted. It's 89% or 90% approx. So maybe for my future scope of improvement, I have considered all these points, and this would be considered for my future scope. So I plan to have my research based upon state-wise prediction and district-wise prediction, maybe in year, maybe in a few big course of time for improvement in my paper. So I also have a plan to improvise, and that is to implement a crop yield prediction based upon every year across India and all districts in across as well as India as well as each district in a state. And third one is to develop a dashboard to predict the crop yield based upon the different land areas. So this is what the future scope which I plan to propose. And I also have a plan of inclusion of weather API, so that would work fine, and it is also easy for the farmers as well as for the person who look into this application by considering okay, location as well as the temperature, humidity, wind speed, and rainfall. All these information could be added to the project. It would be an informative. Next one is the crop name prediction, because we can't say that we know all crops to all people. So I thought of having an image processing in that to have an image that is the cropping, the name crop. Okay, to name the crop based upon prediction, what crop it is. So that could be helpful for all the people. Even though we show it as an output graph, so some people would know what crop it is, so it will be helpful. And the next one is predict and present the state of crop and give approximate days for yield. So you might be, let us consider a crop may have 90 days to produce yield. Now we are at 35th day or 40th day. And if I want to know how much days is left out based upon the current growth, so that could also be made possible as my future scope. And so that is what I am planning for. And to develop an application, either a web-based or a mobile-based crop yielding application is planned. And also the last one is the crop recommendation for the next season based upon the soil quality and weather is also to be added as a future scope of my immune plan. So this is what my future plan in my in this research. And the next one is my references, so which I have referred for. Thank you. This is all about my presentation.
Can you hear me, sir?
Yes, sir, I could hear.
Yeah. Any data cleaning technique have you applied here?
Sorry, sir.
Data cleaning techniques.
Yes, sir. For data cleaning, just we are going to find out only the missing words alone. So we'll be finding out, as I already shown here, already in this data cleaning. So I'll be finding out, is there any missing values in the data set? So here I could find in this diagram, the rainfall, there is about 15 data. Just I'm going to drop those content, which is empty here. And after dropping, if you could find that is that 54 data has been dropped out, and it is considered for next stage.
Okay. So have you done any kind of cross validation for after getting the results from all your classifiers?
You mean cross validation means what kind of
Cross validation of the results, because results which you have received, you should validate it against some existing benchmarking state of the art. So have you
no, sir,
done
not
something?
no, sir,
Not.
no, sir, no, sir,
Okay,
not
fine, fine. Thank you.
Yeah, thanks.
Yes. Hello.
Yes, ma'am, I could hear you, ma'am.
Yes, Prasad. Yes,
Yes, ma'am.
you're using regression.
Yes, ma'am.
Yes. So are you performing single variable regression or multiple variable regression?
As of now, I'm using the multiple variable regression, I guess, ma'am. If I'm right, I'm using with multiple variable.
So all the parameters you're considering here, like area,
Yes,
production,
yes,
rainfall, and everything.
Correct.
And have you given the effect of each and every parameter on the crop yield?
Yes, ma'am. Yes, it has been considered here. You could see here, based upon this only, it has been done.
Thank you.
Yeah, thanks.
Thank you for your great presentation.
Thank you, ma'am. Thank you. Thanks for your valuable time.
Okay, so we are moving further to our next presenter, Anne Nguyen, and to present her paper on the title, Using Optimization Algorithm to Improve the Accuracy of the CNN Model on the Rice Leaf Disease Dataset. Dear presenter, you may please start your presentation.
Can you see the screen? Hello everyone, I am Nguyễn and I am presenting our results here using optimization of algorithm to improve the accuracy of the CNN model on the rice leaf disease dataset. This for author of our results here, Wakanda, Nguyễn Văn Năm, me and Nguyễn Hà Nga. The next is the table contents. Here we have five parts here. The first one is the introduction. The next is the proposed method and evaluation, conclusion, and the last is the reference. As I will present it, the first is the introduction. Here, the words regulation play a vital role. Actually, especially in the Asian countries, like the food, last play an essential role in daily news. It contributes significantly to the GDP of the host country. And we can see in the charts in top 10 rice cultivation in the world, and Vietnam we have the like 4 ranked in this. Thus, This right group reduction will be decreased by the right disease, and they maybe this there is some there are some disease in right leaf class, right force, and because there's so many study on right disease dynamo by machine learning and image processing to classify the right disease, and we wish to conduct research can find the best optimization for this. And the next is the proposes methods. And these we are objective in our research here, which one is the lucky data set. We have a data set which consists of more than 7,000 images divided into 5 different random diseases. And we work to use a CNN model to give the nearest difference between all of them and the higher accuracy. In the next, we went training with the many time, dividing the number of training time by different spots, and the highest value we 2,000 or 200 levels. In the next, we have 5 DC, bacterial class, red strip, tango, and brown spot. We have to move on the dataset in this dataset will collected by the Mekong Delta Rice Institute within Vietnam and collect from the table. We want to enhancing this by augmentation methods, and we will split this or 70 and 22 regional components to strength. By the augmentation, total data is more than 24,000 images, and we will throw this image to the CNN model to train this with a fully connected layer, and we have a model can identify the direct disease, and we will use 3 optimization algorithms. So comparing, we have the first one is data rush, advanced machine learning techniques that perform the radial display by varying the learning rates. We have this is the function of algorithm, and the next is the RMS. Algebra is the root mean square comparison. Use the mean square of the radians to normalize the radians, and we have to the function of this. And the last one we use the Adam algorithm, that's ATA, adaptive moment estimation, the adaptive learning rate method that calculates the individual learning rate for different parameters. And Adam we estimate to the first and the second interval of the slope to adjust the learning rate of fixed weight of the neutral network. In the next, we will be presented the next of our presentations.
So now we come to the next point. What's evaluating optimal algorithm for convolutional neural network? First, model evaluation. To evaluate the model when training with the optimization algorithm, we use the accuracy and the loss function cross entropy. Accuracy an instant that is precisely determined from total number of data sets. In other words, it is the correct prediction made by model relative to the total prediction following equation. The loss function evaluates the effectiveness of learning algorithm for the model on the dataset U. It returns a non-negative actual number representing the difference between two quantities, the predicted label and the correct label. In the either case, the predicted label equal the correct label. The loss function should return a minimum of 0. Cross entropy consider a measure of classified performance. Next slide. Next is about result. And after various research, we have some result for their project with the installment of 3 optimal algorithms to evaluate the data sets. The results are obtained in table 2, accuracy comparison table of 3 algorithms. The first contains number of epochs to compare with the 3 optimal algorithms. 200 epochs. It also gives you detail about currency of three algorithms: Ada-Grass, root mean square, and Adam. From the graph in figure 3, it can be seen that Adam algorithm has the lowest amplitude, highly changing too much after only the first 50 epoch. Means why IMS and Ada-Grass are two algorithms with larger variation during epoch. Next slide. It leads me to the next point, conclusion. Next. The research found the Adam optimizer had a better performance. Through the research, the performance evaluation of proposed model and the accuracy of the model with three optimal algorithms are relatively satisfactory. Initially, the deep feature of fully connected layer is extracted and classified into 5 layers corresponding to 5Z. At the fully connected layer, data classification will be performed by activating the submat function to calculate the probability at the output layer. The study provides more understanding about optimization algorithm through the result from evaluation experiment. The result from the above study have evaluated the impact of optimization algorithm on the correct classification of results in the image recognition problem. It helps us make a reasonable choice of algorithm in building, training, and evaluating network model. Next. Next is future research. Further research develop integrated application to match other devices for future work. We will consider integrated and deploying unmanned aircraft system and real-time system on the data collection, analysis, early detection of disease rise, timely limitation, and prevention, preventing the disease from spreading. Moreover, the research will develop a map generation system and epidemic map application. Finally, we will combine the location data obtained from the drone for mapping with the disease detection result on the generated map and evaluate the accuracy of the whole system. Finally, a reference.
Can you hear me?
Yes.
Hello, can you hear me?
Yes, yes.
Yeah.
Hello, can you hear me?
Yeah, I can hear.
Yeah. How will you compare your optimization algorithm with genetic algorithm? Yeah. How will you compare this algorithm with genetic algorithm? Hello. Okay, fine.
Yes.
Hello. Are you
Yeah.
able to hear? Hello.
Can you hear
Are
me?
you? Yes, yes. You said you're going to track the location using a drone.
Yes, we will build the data set. We will train this in the model CNN with three model with three optimization, and we will see to analyze this the chart in the file. We can see.
Okay, okay. Thank you, thank you.
Yes, in the result we will scan with three charts, and we can see analyze it three charts to find which is the best optimization for this.
Okay, thank you.
Yeah.
Thank you for your presentation.
Yes.
And moving further, we have our last presenter Elliot Williams, and the paper title is Difference Equations, Stationary and Non-Stationary Discrete Systems in Block Ciphers. Dear presenter, you can start your presentation. Okay, so Elliot Williams is not in the session. So with that, we have ended all the papers now.
Okay, done.
Yes, sir. So I sincerely thank all the participants and presenters for their contribution in the session, and both of our session chairs for being present in the session. Thank you for your valuable presence.
Thank you.
And ma'am.
Thank you.
Take
Thank
care.
you.
Bye.
Bye.
Yes, so as we have come to an end of the session, I request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay. Thank you so much.